we have in the next 2 hours two purposes. One is to help you get a vocabulary for SCADA, okay? And the other is to give you just kind of a common basic understanding of what all the pieces and parts of a SCADA system actually are. So we're going to talk about, and the way we're going to do this is we're going to start with the stuff in the field and we're going to come up. So we're going to start with field, we're going to talk about communications, talk a little bit about software, and then we'll talk about integration and advanced applications. So kind of coming from the bottom of the system up. So anyways, we'll also try to update knowledge just kind of in a general sense. Talk about field devices. We're going to talk about communication strategies. Now, I'm going to spend a fair amount of time talking about history and legacy kinds of communications, pole response, serial communications. Now, why would that be important in understanding a SCADA system given what today's technologies are? Okay, just note to the class, when I ask a question, I have unlimited patience. Somebody has to answer it, we don't move on. So that way I don't have to talk all the time. Go ahead.
Because that's primarily the technologies that exist in the field today.
That's certainly part of it, although that's rapidly changing, of course. Right. The other thing about all this is a lot of this technology is built up from these old legacy technologies, right? How does technology evolve over time? We come up with something as a technology, and then we add to it and add to it and add to it. But when I kind of unpack it, get down in the bowels, it's still the old stuff, right? So at some level, I'm still moving bits and bytes around. I'm still looking at, binary and ASCII and bits and bytes flying around. At some point, at some level, that's still what's going on underneath. So if I'm going to be able to troubleshoot, if I'm going to be able to understand what's going on, I need to understand the legacy technologies because in a lot of cases, they're embedded into what we're doing. Talk about common SCADA functionality. What are the things that a SCADA system does? And then talk a little bit about how we get SCADA information into the IT world. And then some interfacing stuff. All right, so if you like to read, here's a couple of books you can go buy. Actually, the top one you can go buy. So there's this book published in 2010 by the ISA has got a pretty good overview of the fundamentals of SCADA. It talks a lot more about the field automation and kind of how the signal processing works in the automation part of a SCADA system. And I'm not going to spend a lot of time talking about that. And then this document, if you want to get something free, this is probably, this mil-spec document on SCADA is really quite good. Now the military uses SCADA for command and control. And they've been using it for a long time. A lot of this technology was invented or matured or optimized in military use. So it's actually quite a good resource, and you can download that just by doing a Google search. All right, so SCADA stands for Supervisory Control and Data Acquisition. Why supervisory control? Why the word supervisory? I know y'all are guessing, but that's okay. Yes, sir?
Because the field device actually does the control. The SCADA
right.
system supervises it by sending the...
What's the most unreliable part of a SCADA system? Communications. The field, the further I get out in the woods, the more I lose reliability, right? So these systems are designed that if there's no communications to the host, I still have control in the field. So the RTUs, the PLCs, those field automation devices, what I do is I pass a supervisory set point. So I say, I want you to control to this pressure, and then I read data back. So a system can operate without the host. And the reason we do that is this telemetry is inherently unreliable. Now it's getting better. Technologies are getting better all the time, but it's inherently unreliable. All right, so The other thing about SCADA versus, anybody heard the term DCS, Distributed Control System? So DCSs are what you find in plants, refineries, petrochemical facilities, fractionators. Those tend to run DCSs. If I look at a DCS and I look at underneath how I set it up, configure it, all that kind of stuff, DCS and SCADA look a lot alike, but they're different in a very fundamental way. In a DCS system, the communications between the host and all the field devices is critical. And if I lose communications, I lose control. So they're almost always used on a system inside a fence. And they're almost always on some kind of Ethernet physical communications backbone. I mean, they may bolt in some wireless and some other things to get some points, but the critical portion of that control in a DCS is very different. So SCADA systems and DCS systems are very fundamentally different when you get to how they communicate underneath. So I'm going to spend my time talking about SCADA. All right, so this is kind of an old school drawing. I want to talk a little bit about the history. What do you think the first use of SCADA was? What time frame in history was the first use of SCADA? Anybody want to guess? Older. Actually, much older.
40s.
Much older.
30. 1870.
You're getting close. Now, what is that little diagram across the top? What does that look like? Or telegraph lines, right? So the first use of SCADA was in the railroads because a lot of the railroads were single track and they needed to know where the trains were, right? So you remember seeing all the Westerns on TV? What is always at the railroad station? A telegraph office. Why would that be? Telegraph operator announces when the train leaves and announces when the train arrives up and down the line. So the first uses of SCADA actually date way back into the early days of telegraphy. So all SCADA at its kind of root is built up from simple digital electrical off-on signals, right? So if you've ever been around a railroad, right? So railroads have tracks and they'll open or close. Well, that's a digital signal, right? It's like an on-off switch. The switch is open or closed. If you see a train and you look down a train track, you'll see these arms that are sticking out and a red light over a green light. Again, it's a digital signal. As a train goes by, each one of those, it's actually clicking off and says the train went by, right? So at a kind of a very basic level, this stuff got built up. So what happened in history was we started just doing telegraphy. Well, you get into the rail yards and I'm moving and I'm switching all these cars around. They said, well, you know what? I can take all and put electrical signals out to all these switches and I can bring that back to a control room in the yard. And if you ever go to a railroad museum, you'll see these big displays with all these names and there'll be a red and green light. So they're listing all the switches in the yard and the red or green light's telling you whether that switch is open or closed, right? So that's how it started. And then from there, we started building it up. We got into more advanced electrical control. So old SCADA, it's where this idea of main terminal and remote terminal comes from. So if you think about this analogy I'm using in a rail yard, that big box that had all that electrical wiring coming into it, that was called a remote terminal unit. And what they would do is they would take all those switch indications and switch actuators, if they had actuators on them, and they would physically wire them using copper wire back to remote site, and that became the remote terminal unit, or the main terminal unit, right? So SCADA is built up from simple electrical control. Anybody here old enough to have played with a Radio Shack control system when you were a kid? Yeah, okay. Yeah, just us old fogies. Nowadays they build computers. Anyways, so That's where this stuff comes from. Now, the reality of it is today, SCADA is a very complex set of stuff, right? So one of the challenges with SCADA is you don't really go anywhere and buy it all from one person, right? You've got field devices and multiple manufacturers. You've got, transmitters and, various kinds of sensors and signal devices and multiple vendors there. You got all kinds of communications devices. And you got multiple vendors providing the software and so forth. So really, SCADA, by definition, is a systems integration project. I got to understand all these pieces and parts and pull them together. The other part about this is that makes this challenging, it's kind of the reason we put this class together many years ago when we put it together, is where do I go to get a nomenclature for SCADA? You don't. I mean, it doesn't exist, right? So we tend to learn it kind of ad hoc once we go to work, right? There's no place to go and learn SCADA. I can go and learn networking. There's classes for that. Can't really go and learn SCADA. And we're going to get through some of it. As we go through this, we're going to go through some of the distinctions and try to clarify some nomenclature. And one of the challenges in all this is the people who work in the field and do measurement use the same words to mean different things than the people in the field who work to do automation, who use the same words to mean different things than the people that work in the back office, right? So we often are in a meeting or on a phone conversation or talking to somebody, and we think they understand us because we're using the same words. And often we don't understand one another.